Okay, welcome back. We're talking about grid computing on page 235. So combining multiple machines together, they could be physical machines, they could be virtual machines, or in a bizarre way of thinking, they could be machines over the internet that you can help in. Believe it or not, there are a couple of distributed computing things out there. Here's one called folding at home. You install this, well, let me explain what they're really talking about. It's pretty easy for scientists to figure out the chemical link in a protein. Okay, they know, this carbon atom is attached to this, the actual chemical formula. But what they don't know is how this long chain gets all wadded up, because proteins are kind of wadded in a ball. And so, this part is touching that part, like a ball of yarn. And so the computing horsepower required to try every single possibility of twists and turns and folding of these proteins is just astronomical. So oddly enough, they allow you to participate. You can install a piece of software on your machine, so when you're not using it, like in the middle of the night, it'll go download a piece of the puzzle, your machine, and they use your machine to process the stuff and then send the results back. I mean, that's pretty doggone cool. You can participate in figuring out how proteins are put together. I mean, you could help, cure cancer or something, right? So this is actually a pretty cool thing. There used to be one called SETI at Home, the Search for Extraterrestrial Life, where, they were receiving signals, but they didn't have enough processing power to process them all. So in the middle of the night, your machine would download, the chunk of signal, and you would run signal processing on your machine and then, send it back up. Kind of cool. Okay. So this is all about dividing a task into individual pieces, So let's say I had, my grid computer. Let's just talk physical for a minute. Let's say I had 10 identical machines that had 128 cores each, right? 10 machines. I need some very specialized software that would take the task and break it up into 10 chunks and send one chunk to this machine, one chunk, and then manage them to make sure they're all working, and then, send the data to those machines, receive the data from the machines, right? As an awful, grid computing is a little complex because of all the management requirements. So I need some sort of algorithm to be able to add or remove a machine, like particularly on these guys, like on folding at home. They have to be able to go in and, add a new machine, take a new machine away, right? And so, yeah, you can save some money using grid computing. I mean, for example, I could have a specialized grid computer. I mean, for example, let's say I'm doing folding, and I'm doing it in the physical world. My servers don't have to have a graphics card at all. That's not what they do for a living, right? All they do is just compute. It's just a compute unit. That's all they do. Okay, so I can save money because I don't need video cards. I don't need fancy LED lighting and and all that kind of stuff. The whole concept of grid computing is compute efficiency. Okay, that's it. That's what they're after. It's not about reliability. If one of them goes down, like most grid computers don't bother with having fancy RAID configurations and backups and all the rest of that stuff, because these things are independent little things that kind of work on their own piece of the puzzle. And if one of them drops off, fine, just go get another one, pop it in. So their whole thing is about efficiency for the compute resources. Okay. All right. So Blade computer on page 237. So a Blade computer is kind of sort of along the same lines, except you buy this cage that you put in your rack, and then you have a blade. You have a computer, and the entire computer, it's got the CPU, RAM, disk, everything, and you just slide it in this slot, and doing, it magically shows up boing, as a machine that you can provision. And the idea is, let's say I really want a really super duper grid, but I can only afford 4 machines, so I plug in 4 of these guys, and then later on I get some more money, and so I buy 4 more, and so I just plug them into this specialized container physical rack that allows me to add more CPUs, entire CPU on a card. It's just kind of like an edge-mounted card. You just slide it on in. It's pretty doggone cool. Anyway, self-contained card, and you can. They're essentially all the same. So, like if one of them died, you just pull it out and go pop another one in. Right? Not that big of a deal. It's more cost effective because once again, I'm sharing like the chassis and the fan and this and the power supply and all that stuff. I don't have to pay for like separate power supplies every single time and cooling every single time. I pay for that just once. How much more is it expensive? I mean, more cost effective is it? Nah, it used to be, maybe, but not now. Servers are getting kind of sort of cheap. Okay, cloud computing, page 238. We've talked about this a bunch, but basically I'm renting capacity. I don't know exactly how much compute power I need, so let's say I'll take 4 cores. And then later on I go, oh, that's not enough, let's go to 8. And it could be so that during periods of high use, the classic example I always talk about is you're a tax preparing business. And so, during the month of April, you need lots of compute power and lots of bandwidth and lots of storage. But in June, well, no. So you dial up the resources for the periods of time that you need it, and you pay more. And then you dial it back down during the rest of the year, and you pay less. That's actually kind of cool. So there's 3 definitions for their cloud computing. From a consumer point of view, this is basically just where I store my stuff. I've got a OneDrive out there, and I don't really know where it is. I mean, I have no idea what server it's on or what city it's in. I just put my stuff out there, and then, okay, I'm done. A business is all about this elastic compute thing, where elastic capability, where I can expand or contract the amount of resources. That's a really cool thing from a business point of view. And if you're an IT person, your concern is, hey, I don't have to administer this thing. Well, some administration. But, depending on what type of cloud computing, maybe I have somebody else is doing the maintenance. Someone else is doing some of the operation stuff. Okay, so let's talk about on-demand services. This is kind of a key point, this elastic scalability. That's a very important point. Hint, 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 hint. So you could even have it automatic, although this is a little dangerous. But you could set it up so, if the CPUs, let's say I pick 4 cores for my VM, and you can set up this piece of software that monitors all your VMs, and when the average amount of time on your CPU goes above 60, you can say, well, let's add 2 more cores automatically. By the way, in a lot of scenarios, you can actually add 2 CPU cores to a running VM without rebooting. Ooh, wow. The data center versions, for example, of Windows Server 2019 can handle more CPUs magically appearing or CPUs magically disappearing. They can alter the scheduling of resources when those changes occur. That is doggone cool. Okay, so cost benefits. So, what's the most costly part of your server? Is it the hardware? Is it the software? No, it's probably the labor, right? It's the administration part. Servers are okay. I mean, you can buy a decent server for, $15,000. But I'm not going to be able to hire an IT guy to manage it for $15,000. And the software, that's getting pretty doggone cheap. So they also talk about the thing called an opportunity cost. If you are quick and nimble and can fire up a VM in an instance. By the way, would you care to guess how long it takes if you went to Microsoft Azure and say, I'd like a new virtual machine? How long would it take after you hit the button before the server became available? About 2 minutes. It is dang quick. So missed opportunities. There's an entire section in the book talking about how if you're quick and nimble and you can fire up a VM and go do something and, perhaps compete on a contract that no one else could, because other people are like, oh, there's no way in heck we could, produce a server to be able to do this so we can compete on this contract. Well, you can, because you can do it on a VM. Okay. So software as a service. So software as a service is a special type of cloud computing where basically you don't manage the VM at all. So the example I'm going to use is SQL, Azure SQL, so a database. So I don't have an administrator account on the server. I don't reboot the server. All I have is a web interface to SQL services. That's it. Somebody else is responsible for doing patches on the machine, right? I have practically no responsibility. All I have is I'm an administrator over the SQL Server instance. That's it. I don't see what else is installed. I don't see what other customers are using the machine. It is all I get is my one tiny little piece, and I don't have to worry about anything. I don't administer the server. I don't do backups. I don't do anything at all. Google Apps is kind of sort of similar to that. I mean, for example, if I fire up a Word document and throw it in Google Apps or something, then their Google document stuff. Again, I don't administer that server. I mean, I don't have like an administrator account. I don't even know where the server is, right? Okay. Anyway, by the way, the software as a service and this whole cloud computing thing, it's been around really for a long time. It's just that just now, well, recently, the internet speeds to like the home and businesses have been fast enough to make this a viable option. I mean, for example, if you're on a dial-up, no, you are not going to use cloud computing. I'm sorry, it ain't happening. Sorry. So yeah, you had to wait until we had high-speed internet. Okay, appliances on page 241. So appliances is a dedicated device. So I'm going to show you an example. This is a network attached storage, a NAS box. It's got individual drives in it. Each one of these drives is in a RAID configuration. So, I have a drive that plugs into this guy. And this guy, all you do is just plug it into the wall and plug in a network card. So this is a full computer running Linux. But there's no place to plug in a keyboard or a mouse or a video card. This is just an appliance. Most people do not even know what operating system is on here, nor do they care. So an appliance is one of those things where you plug it in and you don't do any administration because no administration is required. Okay, I'll admit, there's a web interface where you go here and maybe you need to go get an update from Synology or something, but that's about it. Okay, so the idea is that Synology makes these guys, they have an awful lot of these network attached storage guys. So I like this whole concept. There's lots of design for for people at home, right? That kind of works. So they have a little scenario, dealing with ransomware, how they can solve your problems by backing up all your stuff. Okay, so Synology is a company that makes network attached storage things. I kind of like them. Okay, so I'm going to go down here to Central Storage, and here's all the things you can buy. I have a 6-disc version of this guy. All right, cool. All right, so network attached storage. Typically, you don't mess with the operating system. Most people don't even know what operating system is on there, nor do they care. Okay, so an appliance. So are appliances good or bad? Well, yes, it is possible there could be a vulnerability in the NAS software, yes. And so you would have to be kind of having your ear to the ground to make sure that you kept the patches up. Okay. All right, moving on. On page 242 is the hybrid. This basically means a combination of cloud and on-premises. You could have a cloud-first way of thinking, where you're trying to move everything to the cloud. Or a cloud only, where basically you don't have any on-premises compute power or storage at all. Okay, and it's sort of like don't try to put everything on there at the exact same time. In other words, when you're trying to migrate to the cloud, don't attempt to go in there and say, well, I'll do everything at once. No, just move over 1 or 2 services at a time. It's back to that small batch principle. Okay, we've made it to the end of this chapter, and stay tuned for the next chapter.